So this is a big, ugly polynomial, but the first thing you should notice is the polynomial is of what degree?
6.
6. Because it's a polynomial of degree 6, there are at most 6 real zeros. Okay? And then the next thing that we did is looked at Descartes' rule of signs. To determine how many positive and how many negative real zeros the function might have. So remember, with Descartes' rule of signs, we look for the number of sign changes in f of x. So here I'm going from positive to positive. There's no sign change. Here I'm going from positive to negative. That's one sign change. Negative to negative, no sign change. Negative to negative, no sign change. Negative to negative, no sign change. So based on that, how many positive real zeros should I have?
1.
Yep. There will be one positive real zero. So now what I'm going to do is figure out f of negative x. And here's the little shortcut here that I'm hoping you picked up on. When the exponent is even, the value doesn't change. When the exponent is odd, the sign changes when you figure out f of negative x. So this is going to be x to the 6th minus 4x to the 5th plus 16x cubed minus 37x squared plus 84x minus 84. Keep the sign changes. There's one sign change from positive to negative. There's another sign change from negative to positive. A third sign change from positive to negative. A fourth sign change from negative to positive. And a fifth sign change from positive to negative. So holy cow, we have 5 sign changes there. You see that? And for that reason, there will be 5, 3, or 1 negative real zeros. Because remember, it's the number of sign changes or that number less an even integer. So that's the next piece. Let me write the function down again so that we don't lose it. F of x equals x to the 6th plus 4x to the 5th minus 16x cubed minus 37x squared minus 84x minus 84. I think the next thing we wanted to do here is list the potential rational zeros. Remember, to find the potential rational zeros, we list out all factors of the constant and all factors of the leading coefficient. The factors of the constant we call P. So P is 8, or the constant is 84. So we got to factor this. It's what, 184, or you could have 2 times 42, right? 3 doesn't go in. It could be 4 or 21. 5 doesn't go in. It could be 6 and what?
14.
14. It could be 7 and 12. Does 8 go in? Nope.
No, it's 10.5.
Does 9 go in?
Nope.
10 doesn't, and 11 doesn't, and then we're back to 12. So that's the process I would follow. Just go down one by one with the integers and then divide it into the number until you've exhausted the list, like we just did. And because, by the way, because the leading coefficient is 1, that's just plus or minus 1. So once we know P over Q in this case. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 6, plus or minus 7, plus or minus 12, plus or minus 14, plus or minus 21, plus or minus 42, plus or minus 84. That's quite a long list. Remember what we wanted to do to kind of pare that list down is draw a picture of the function. So here we have x to the 6th plus 4x to the 5th minus 16x cubed minus 37x squared minus 84x minus 84. This is what I get. Is that what you're getting?
Yeah, I got that too.
And so there's a 0 that's somewhere between -2 and -3. There's a 0 that's -2. And notice how the graph is just touching there, which suggests that's a 0 of even multiplicity. And then I have a 0 over here between 2 and 3. And I think that's all I got. Yeah, this just goes way off the screen. So I'm not really worried about a complete graph with these problems. All I'm really worried about is trying to use the graph to help me pare down that list of potential rational zeros. So I'm just going to grab this portion right here and be happy. So I'm going to say from the graph, it looks like -2 is a 0 of even multiplicity. Therefore, f might have a factor of the form. This is where you have to be really careful. It's going to be a factor of the form like x plus 2 to the 2nd or x plus 2 to the 4th, something like that. You follow? So here I'm going to cheat a little and ask GeoGebra what f of -2 is. And you see how it says 0?
Mm-hmm.
And so because f of -2 is 0, I know x plus 2 is a factor. Okay, so we'll just say because f of -2 equals 0, x plus 2 is a factor. And now we're going to go down the synthetic division route. -2 goes outside. And then I write down all my coefficients. 1, 4, -16. Oops, I'm missing some. No, yeah, 1, 4, 0, -16. I have to put 0 in because x to the 4th power is missing. You see that? In the function?
Yeah.
And so 1, 4, 0, -16. 1, 4, 0, -16. And then -37, -84, -84. -37, -84, -84. Sound good?
Yep.
All right, now I'm going to go a lot faster on this synthetic division. Bring down the 1. Negative 2 times 1 is negative 2. Add vertically. 4 plus negative 2 is 2. Negative 2 times 2 is negative 4. 0 plus negative 4 is negative 4. Negative 2 times negative 4 is 8. Negative 16 plus 8 is negative 8. Negative 2 times negative 8 is 16. Negative 37 plus 16, I think, is negative 21. Negative 2 times negative 21 is 42. Negative 84 plus 42 is negative 42. Negative 2 times negative 42 is 84. Negative 84 plus 84 is 0. That's what I thought. We knew that we were going to get a 0 remainder because we knew we had a 0 of the function. And so now I can write f of x like this. I can write it as x plus 2. And then remember how this works? That's the constant coefficient on x, x squared, x cubed, x to the 4th, x to the 5th. And so I have 1x to the 5th plus 2x to the 4th minus 4x cubed minus 8x squared minus 21x minus 42. And the gig here is we're only now going to focus on this piece right here. Remember that negative 2 looked to be a 0 of multiplicity 2. So if in fact negative 2 is a 0 of multiplicity 2, that would mean that x plus 2 should be a factor of that expression that I have underlined in blue. Let me say that again. Negative 2 is a 0 of even multiplicity. Therefore, we were thinking that x plus 2 quantity squared might be a factor. I only have an x plus 2 here. Therefore, the other x plus 2 must be buried in here as a factor. And so we're going to perform synthetic division again, but this time we're going to work only with the expression underlined in blue. Because the other guy is already factored. X plus 2 is completely factored. I can't go any further. Bring down the 1. Negative 2 times 1 is negative 2. 2 plus negative 2 is 0. 0 times negative 2 is 0. Negative 4 plus 0 is negative 4. Negative 2 times negative 4 is 8. Negative 8 plus 8 is 0. Negative 2 times 0 is 0. Negative 21 plus 0 is negative 21. Negative 2 times negative 21 is 42. Negative 42 plus 42 is 0, which is what I expected because I knew x plus 2 was buried as a factor in that expression underlined in blue. So now f of x equals x plus 2 from up here, and then times another x plus 2 from this factor, and then times the quotient, which is x to the 4th plus 0x cubed minus 4x squared plus 0x minus 21. The expression that I'm about to underline in blue right here is quadratic in form. That is actually factorable. Here's how. What I'm going to do is factor this as x squared minus 7 times x squared plus 4. Remember, I'll do this on the side in green. So if you have x to the 4th minus 4x squared minus 21, x to the fourth can be written as x squared all squared, because when you raise an exponent to an exponent, you multiply. 2 times 2 is 4. And then I have minus 4x squared and minus 21. You remember we would let u equal x squared. So now you have u squared minus 4u minus 21. And there you're looking for, hey, what two factors of negative 21 add up to 7? That's minus 7 and plus, oops, this should say plus 3 here, my bad, and plus 3. But we don't want to know this factored in terms of u. We want to know it factored in terms of x. So I put x back in, x squared minus 7 and x squared plus 3, like so. So all the stuff that we need you to remember from those other courses is starting to pop in to play here. Now, we can't factor this any further, but what we do want to do is identify the zeros. Well, x plus 2 quantity squared is x plus 2, I'm sorry, x plus 2 times x plus 2 is x plus 2 quantity squared. And then for this x squared minus 7, I kind of lied to you that we can't factor it. We can't factor it over the integers, but we can factor it over the reals. Because if we want to know the other zeros, we want to solve x squared minus 7 equals 0, which means we want to solve x squared equals 7. And we use the square root property that says x is plus or minus the square root of 7. So if 7 is a 0, I'm sorry, if square root of 7 is a 0, that means x minus the square root of 7 is a factor. If negative square root of 7 is a 0, then x plus square root of 7 is a factor. Now x squared plus 3 cannot factor over the real numbers, and so it's prime. And so now here's what we know. Negative 2 is a 0 of multiplicity 2. Square root of 7 is a 0 of multiplicity 1. Negative square root of 7 is a 0 of multiplicity 1. So now let's look back at everything that we learned or surmised about this way back when. There are at most 6 real zeros. I only found 4. There will be 1 positive real 0. I have 1 positive real 0, square root of 7. There will be 5, 3, or 1 negative real zeros. I technically have 3 negative real zeros. The negative 2 is a 0 twice, and the negative square root of 7 is a 0, so that's 3. I have, right? And I think that's everything that we surmised. 2 is in my list of potential rational zeros. Square root of 7 is an irrational number, so it's not going to appear in my list. So that is as complicated as these problems can get. So if we're able to follow that one, I think we'd be good to go.